Ready?
Good morning, sirs, ladies and gentlemen. It's my pleasure to open the last day of the annual conference. And today, the name of the panel is Water Resources and Management. And saying so, I would like to give the floor to the moderator, Professor Cyrus. Sir, the floor is yours.
Yursky, we have this is the last panel. We've been going not so far. We have the first paper by Mr. Nikola Bobchev, Dimitri Berov, Stefan Klein, and Yusuf Karminflov. It's a face-to-face presentation on baseline survey of microplastic pollution in coastal marine sediments along the SW Bulgarian Black Sea coast. The second paper by Professor Nikolai Rachev online will be on the role of precipitation variability in water content for reservoirs in central and western Bulgaria for the period 2016-2019. We have a short break, 10-15 minutes, then we have another presentation face-to-face by Dr. Tatiana Orekhova, who will be presenting on behalf of the group, Professor Dr. Yavor Stepanov and Emil Slonavsky. That will be on the solar and climate impact and influence of groundwater level variations in 2 wells in England. And the final presentation will be by Ms. Svetlana Mikova, who will be presenting on behalf of the group, Valentina Doncheva, Bremeva Stepanova, Elisa Stepanova, Dmitry Popov, and Marina Panayotova. That will be online. And the topic will be the plastic ingestion by Kostrena and Kristiopoulos truncates from the Black Sea. So we'll start with Mr. Nikola Bobchev. The floor is yours. Welcome.
Good morning, everyone. For me, it's a pleasure to be here and to present you our results about microplastics in marine sediments along the southern Bulgarian Black Sea coast. I'm Nikola Bobchev from Institute of Biodiversity and Ecosystem Research. Some information about myself. I have been monitoring plastic pollution along the Bulgarian Black Sea coast during the last 5 years. Actually, plastic pollution is a very interesting topic for me, and I hope it will be also interesting for you. And next slide, please. Okay, thank you. In the next 15 slides, I will present you the study area, the field and lab methods, and also the results. Next slide, please. Previous? Okay, but the first, what are microplastics? They are okay. Thank you. This way. This way, okay. But the first, what are microplastics? There are different terms about plastic waste. Macroplastic waste, mesoplastics, microplastics, or also nanoplastics. And microplastics are plastic waste between 5 millimeters and 1 micrometer in size. But this size is not always the same. The size can be different in the different studies. So the upper size is biological based. The upper size is biological based, but the lower size can be different. The lower size is dependent on sampling, plastic extraction, or plastic identification. For example, if you identify microplastics with FTER spectroscopy, you can identify plastic particles up to 20 micrometers. But if you analyze microplastics with microscope, you cannot see or identify microplastics lower than 250 or 200 micrometers. And all this make comparing studies about microplastics very difficult. But although there are difficulties in comparing studies about microplastics in sediment, there's still no result from many regions in Europe, and the Black Sea is one of these regions. There are only few studies about microplastics in sediments, mostly from Romania or Turkey. And our study area is located southern than Burgas. At the study area are three different sites, and it's very interesting to see the concentration in these three different sites. Site one is Sozopol Bay. This is an area with very anthropogenic, with very high anthropogenic impact. There are tourism, um, wastewater, littering along the coast, uh, shipping, aquaculture, fishing, and all these are microplastic sources. Site 2 is near river mouth. Site 2, there is Butamu river mouth. And actually, rivers are main source of microplastics. And it's interesting to see how is the microplastic concentration in sediments there at river mouth. And site 3 is Parashkeva Bay, St. Parashkeva Bay. And this area is a natural protected area and is used as a reference point um, in studies about water quality along the Bulgarian Black Sea coast. So, what are the objectives of this work? At first, determination of suitable methods for microplastic extraction from sediments of the Black Sea and establishment of a microplastic database. Determination of baseline level of microplastic solution in coastal sediments in the southwest Black Sea. But it's also interesting to see the microplastic concentration in the three different sites near urban coastal, near river mouth, and natural protected area. Also interesting is the determination of level of microplastics in the different types of sediments. How we're taking the samples. The beach sampling, 100-meter transect were chosen from each beach. And from each 100-meter transect were taken 3 random samples from the most pronounced rock line. The most pronounced rock line is the line at the beach with the highest accumulation. A total of 18 samples were collected. The seabed sampling, a Van Veen graph sampler were used for the seabed sampling. 7 samples were taken from a depth between 4 and 6 meters, and 5 samples were taken from a depth between 20 and 25 meters. How we extract the microplastics from the sediment? We used a sodium chloride solution, and sodium chloride solution has a 1.2 gram per cubic centimeter density, a maximum saturated sodium chloride solution. And with this solution, you can extract a lot of plastic types. Or actually, you can extract more than 65% from the plastic production. It's also to say that at the beach, it's expected that at the beach are more plastic types with lower density than the density of the seawater. So you can use the solution to extract a lot of plastic types from the beach samples. We used also the unit from Kopek et al. And this is very small and practical to use unit. You mixed 50 gram of sediments, 600 milliliter of sodium chloride solution. And after 15 minutes of sedimentation, the unit is closed and the upper part is filtered and you have the microplastics and the sediment sink at the bottom. We tested the unit and the solution, and it shows a very good results. Recovery rate is 94%, and the 5 most commonly produced and investigated type of plastic can be extracted with this unit with this solution. But for the microplastics from the seabed, it's expected that at the seabed are more plastic types with higher density than the density of the seawater. So you need another method to extract more plastic types. And we used another method. If you mix sediment, distilled water, and oil, plastics will stick to the oil because plastic has um, lipophilic properties, and with these lipophilic properties, plastic sticks to the oil, and so you can extract microplastics with oil, and this is very harmless and cheap method. We mix 15 grams sediment, 16 milliliter distilled water, and 10 milliliter oil. After 1 hour of sedimentation, the whole unit were placed in freezer. The whole unit is covered with aluminum foil to reduce the potential contamination. And the whole unit is placed for 3 hours in freezer. After freezing, the lower part of the unit is removed, and the sediment were washed off with warm distilled water. And after melting, the solution and the oil will filter it, and you have the microplastics. I know there is a lot of text, but I think this is very important point when we speak about microplastic pollution. Microplastics are everywhere in our clothes, shoes, and it is very easy to contaminate the sample. And you must make a lot of steps to reduce and to identify the self-contamination. And we made a lot of steps. For example, choosing the right clothes or placing the control filters to evaluating the air contamination in the lab, but also testing the O units and the O solutions for microplastics. And if you analyze microplastics with a microscope, this takes a lot of time. And this time, when you work with the microscope, is potential contamination time. And we covered the filters with glass microscope slides, but these glass microscope slides has also microplastics, and we must also identify the microplastic there. So the results at first, microplastics were found at each sampling point. The microplastics vary or range between 200 and 500 particles per kilogram dry sediment at the beach, and between 500 and 1,100 particles per kilogram dry sediment from the sea bottom. We have also higher contamination at the site 1, Sozopo Bay, the site with the high anthropogenic impact, and lower contamination at the site 2 and site 3. And this show us actually that site 2, the site 2 is Roputamo River Mall. At this study area, river isn't main source of microplastics. We have also a gradient at the site 1 at Sozopo Bay. We have higher concentration near Sozopo, the beach, and lower concentration near Chernomorets or Cape Chervenka. Here you can see also better the gradient. The yellow are samples from the beach, and site 1 shows us the gradient. At site 1, we have higher concentration of microplastics from the beach and from the samples in a depth between 4 and 6 meters. But in a depth between 20 and 25 meters, we have a pretty similar microplastic concentration in the whole study area. Okay. From each, okay, we have 3 types of sediment: sand, silt, and gravel. And there is no correlation between sediment size and microplastic concentration. Also interesting is to see the distribution of microplastics by shape and color. In total of 88% of microplastics are fibers, but beach samples show higher diversity. Actually, fibers are most common type of microplastics in microplastic research, but there are many reasons about this. For example, especially for our study area, There is wastewater discharge and the conclusion. Microplastics are found in sediment of the southern Bulgarian Black Sea coast. The urbanized site shows higher amount of microplastics than the other two sites. And the river, Roputamu River, doesn't show up as a significant source of microplastics. Fibers are also a most common type of plastic. And it's also important to see, to say that there is no common method to identify microplastics. And this can be taken as a message for the future works. In the determination of microplastics from sediments, different methods are used for sampling and processing, for identification of microplastic, determination of self-contamination, and all this makes comparing studies very difficult. And thank you for your attention.
Thank you very much. Thank you for Rich presentation. We'll move to the next paper, virtual presentation by Professor Nikolai Radchev on the role of precipitation variability in water content at 4 reservoirs in central western Bulgaria for the period 2016-2019. Professor Radchev, the floor is yours.
Can you see my screen, my presentation?
Yes, it works. Thank you very much.
Okay, thank you.
Yes, yes, we can see your PowerPoint.
It's PDF. Okay. I will speak about the role of the precipitation variability in water contents of 4 reservoirs in central western Bulgaria from the period 2016-2019. Why I did this research? The motivation was to find the reason for the water supply crisis for the city of Pernik, Bulgaria in 2019. Some of the observed hydrological changes are the increase of the surface temperature, increase of the frequency of and intensity of the floods and droughts, decreases of the snow cover, changes in the precipitation patterns, and many others. Mainly they are related to climate change, significantly affect the water storage in the reservoirs, and careful regulation of water use is needed. Where are the 4 reservoirs under examination? Okay, we have here reservoir Iskar. Here in the Rila mountain, we have reservoir Beli Iskar. They are connected with the Iskar river in Bulgaria, and after that we have 2 other reservoirs connected with the Struma river. These are reservoir Studena and Yakovo. Why I chose these reservoirs? Because they are used mainly for supplying drinking water of some cities and suburbs around them. Okay, for the purpose of this study, I used 5 meteorological stations. They are synoptic stations in the World Meteorological Network, World Meteorological Organization network, and these weather stations are the first Sofia. After that, I choose other 4 weather stations. They are located in the territory of nearest Serbia. This is Dimitrovgrad, Niš, Leskovac, and Vranje. Why I chose these meteorological stations? Because, as you know, the rain in Bulgaria and the atmospheric fronts, they arrived primarily from west, northwest, so they can bring rain in the area of study. Data I used are free. They are everybody can download from the internet. This is the data from the European Climate Assessment dataset. After that, the SYNOP codes records can be obtained from OGMET. Also, I used some information from the National Meteorological from Bulgaria, Meteo BG, and from Serbia. And some information I used for the contents of the reservoirs from the Ministry of Environment and Water of Bulgaria. Okay, let's to see in the time we speak about climate change, what is the temperature change in Sofia stations for the last 60 years. Okay, here on the graph you can see the seasonal change of the temperature in Sofia for the periods 1960 till 1918. We can see that we have warming, and this warming is for the all seasons. And here we can see the annual trends and seasonal trends of temperature degrees Celsius per 10 years. Okay, the conclusion is that if we have warming, we will have more need for water, and we have strong evaporation. Here is only the anomaly from the last, okay, not last, from the years 2016 till the beginning of 2020. We can see that except 2016, the next years we have 3 years with higher temperature than the normal temperature for the period 1961-1990. And following the investigation of National Institute of Meteorology and Hydrology of Bulgaria, the 2019 was the warmest year in Bulgaria since the beginning of the meteorological records. The annual temperature, average annual temperature, was more than 2 degrees above the normal, climatic norms. What about the precipitation? This is again for the Sofia weather station, and with the columns we can see the seasonal precipitation, and with the curve we can see the annual precipitation. For the periods, all the periods, we have some increase of the precipitation comparing with the normal period from 1961 to 1990. But the main feature we can see here on the graph is that for the past, let's say, three decades, we have strong interannual variability. We have years, for instance, here, 1993, 2000, after that, 2011, 2012, and also 2019, we have low precipitation. And we have other years, for instance, 2014, with very high precipitation. We can, on the basis of this monthly data for the precipitation, we can calculate the so-called standardized precipitation index. And here is this index for the station of Sofia. Here we can, on this graph, we can clearly see these droughts in 1994. We know that we have the water crisis supply in Sofia also. There was, but not so heavy water crisis in Pernik during this time. After that, we have some years with normal and above the norm precipitation, also SPI index. And here we have negative values of precipitation index, especially years 2011, 2012, and also here at the end of the graph 2018, 2019. If we have values between -1 and -1.5, we have moderate drought, and very dry conditions we have if the value of the SPI is between -1.5 to. So we can see on this graph that we have some periods with very dry conditions especially here in Sofia. On these graphs, we can see the water contents in percents of the maximum of the water in the dams for the Beli Iskar, the left figure, and Lake Yakovo. Note that for the boats, here we have these two curves, yellow one and dark red one, and we have during these periods we have lower values in the these dams during 2011 and 2019. Also here we can see, and the close was similar was situation in 2017. And okay, there is it's visible. There is strong annual and interannual variations. For the rest two dams, the left is Iskar reservoir, and here on the right is the Studena reservoir. Okay, here we have also interannual variability, but we can see on the left graph for the Pernik Studena reservoir that we have an anomalous graph on 2019. And here we must note that we have vertical axis different here for the Iskar dam, we have the minimum 60%, so we can say that during these 11 years, there was no time when the filled volume of the lake, of the reservoir Iskar is less than 60%. Not this the case for the Studena reservoir. The minimum was achieved here in the end of 2019 and in the beginning of 2020. It was approximately 15% of the volume of the dam. Okay, how we can react on these changes in the precipitation and to prevent water crisis? Here is one example. I saw that one of the years with the negative values of SPI index was here 2011, 2012, and the example is for the Belly Iskar reservoir. Here, at the end of 2011, we can see that the volume of the reservoir, the water in the reservoir, is lower than normal, and immediately we have the lower consumption. This is one example for the proper water management for the lake of the reservoir for Belly Iskra. On this graph, we can see for the period from 2016 to the beginning of 2020, the volume filled for the four reservoirs under consideration. And we can see, for instance, this blue curve, Lake Diakovo, we have lower volume in 2017 and 2019. Okay, some decrease of the water contents we have also for the reservoir Iskar, the biggest one, but the variations was from 70 to 90%. So this means we have good management of water resources for the reservoir Iskar. Not this is not the case for the Pernik reservoir. You can see the problem with the volume of the Pernik dam during 2019. Okay, let's compare precipitation, the upper graph. In these 5 meteorological stations, so Sofia, Dimitrov, Lesko, Snish, and Vranja, we can see that the precipitation has a similar pattern for these 4 stations, except some points when in single station there was strong precipitation, intensive precipitation, but these are isolated cases. If we calculate the SPI index, we can see that during the in the beginning of 2017, during the summer of 2017, autumn in 2018, and also spring and autumn of 2019, we have very dry conditions. So this can lead to water problems with water supply. Here is the SPI 6 monthly index. When we can see here the periods of the end of 2017. We have lower than zero negative values of SPI 6 index, and here we have some long periods starting from the end of 2018 till the beginning of 2020, when the SPI 6 index has negative values. What can see on the graph of the Struma River runoff. This is the measurements near the Boboshevo. And here we have that the maximum in spring for the years 2017 and 2019, there are no such maximum. And we have lower, maybe, okay, let's start. 4 times lower river runoff than normal during these 2 years. So, as a conclusion, we can use the values of SPI 3 to show the presence of 3 periods of severe dry conditions in the region under consideration in the autumn of 2018 and early spring and autumn of 2019. The similar growth was observed in 2017, but this was moderate and did not lead to water supply problems. The main reason for observing growth in 2019 is the low precipitation in February and March 2019 and the associated small thickness of the slow cover. Despite the adverse meteorological conditions, problems with water contents arise in only one of the 4 reservoirs under consideration. This is the reservoir of Studena. And this indicating that the water freeze for the town of Pernik in 2019 could be avoided by adequately regulating water consumption for Studena reservoir. Here, just to mention that I found another 2 articles studying the problem with water supply for town of Pernik during 2019. And finally, this work has been carried in the framework of the National Science Program, Environmental Protection and Reduction of Risk of Adverse Events and Natural Disasters. Okay, thank you for your attention.
Professor Rachev, thank you very much for your efforts. This very informative paper. We'll have a short break until 9:55 a.m. and we'll reconvene in 9:55. Thank you very much.
iPhone. iPhone. Аз не чувам нищо от следващото. Има някакъв технически. Добре.
like to announce a small change to the program. Now we'll have Mrs. Svetlana Mihova will be presenting on behalf of the group with Valentina Doncheva, Kremeva Stefanova, Elita Stefanova, Dimitar Poffer, Marina Payatonova, plastic ingestion by Fushuna, and Tursiops truncates from the Black Sea. This will be an online presentation, and then we'll move forward with Dr. Tatiana Orechova's presentation on solar and climate impacts on groundwater level variations in 2 wells in England. Mrs. Mihova, the floor is yours. Thank you.
Thank you. Good morning, dear colleagues. My name is Svetlana Mihova, PhD student at Institute of Oceanology in Varna, Bulgaria. And I will present plastic ingestion by Phocina, and Tursiops truncatus from the Black Sea. Although marine plastic waste is recognized as a global problem, there is insufficient data on the extent of microplastic pollution in the Black Sea. In this study, we consider mainly criterion D10C3 indicators 2 and 5 from descriptor 10 marine litter to assess the level of threat to biota and ecosystems from the Marine Strategy Framework Directive. All samples had been collected in 2020 and 2021 from bycode stations in the bottom cell units targeting turbot and at 65 to 84 meters depth. The only exception, harbor purpose, that was entangled in a stationary pound note. All the carcasses has been fresh, code 2. Stomachs and intestines were collected in glass jars with alcohol and frozen at -20 degrees Celsius. A methodology for extraction and analysis of microplastics in biota was chosen. Laboratory analysis reduced cross-contamination. The samples were taught in advance at room temperatures. Stomachs and intestines were weighted, then chopped, and organic matter was removed with filtered 10% potassium hydroxide for 2 to 3 weeks at room temperature in glass containers covered with metal foil. Then the solutions were filtered on nylon filter mesh with a pore size of 75 micrometers. On the Olympus stereo microscope, protected by transparent polymethyl metacrylate surfaces, the presumed plastics are determined by type, color, and size directly from the glass petri dish, which only opens to check the structure of the detected particles. Microplastics less than 5 millimeters were found in 2 out of 2 bottlenose dolphins from the dolphin family, and micro and mesoplastics were found in 24 out of 29 harbor purpose from the purpose family. A total of 197 plastic particles were recorded in 26 individuals. 84 of all the examined individuals. The average number of plastic particles per station was 6.35 particles per individual for all individuals, and 7.6 particles per individuals for those individuals with injected plastics. The most common types of plastics identified were fibers, followed by fragments, paints, films, foams. And the rarest registered were primary microplastics, 1 gray pellet, and white transparent. The most common plastic color found was gray, followed by blue, black, transparent, green, white, red and pink, and brown. Vast majority, 94% of the recorded plastics were microplastics, less than 5 millimeters. Small microplastics accounted for 62% of all plastic found. Large microplastics are attributed for 31% of all plastic reported. Mesoplastics are attributed for 6.6% of all plastics registered in the study, and no macroplastics were identified. This is examples of identified plastic particles. In the left picture, this is pregnant female with male fetus, Black Sea Harbor purpose. And in the picture in the right are three particles found in her stomach. These are more particles. The two primary particles are on the bottom right. More particles. This is the prey for dolphins. Meso and microplastics were found in 84% of all examined individuals, with 74% of all inspected stomachs and 50% of all tested intestines. Meso and microplastics were found in 48% of the female individuals. In addition, 89% of plastics were found in female individuals. The reason for this could be the vulnerability of the pregnant and lactating female dolphins. Meso and microplastics were found in 83% of male individuals. On the contrary, 11% of plastics were found in male individuals, taking into account the difference in the gender representation in the samples. The average number of plastic particles per citation was 6.35 particles per individuals. This study presents the first result for meso and microplastic pollution ingested by marine mammals in the Bulgarian coastal waters ecosystem. Further studies are needed to identify the spatial distribution of this kind of abundance in the Black Sea. This study was supported by two significant projects, ELTER BG and CNODS. Thank you, colleagues, for your attention.
Thank you very much, Ms. Mihava, for this compact presentation. We'll have a face-to-face presentation next by Dr. Tiana Orechova. Dr. Orechova.
My presentation. Just a moment. This study is prepared by three colleagues from the Climate, Atmosphere and Water Research Institute. Bulgarian Academy of Sciences. Next, this one. Yes. The aim of the study is to investigate the possible influence of solar and climate indices on groundwater level fluctuations. Two study sites in England were selected due to long time series covering several decades of the observed groundwater levels. Possibility of forecasting of groundwater levels on the basis of common solar and climate cycles is discussed and analyzed. These are two study sites, Hooklow and Chilgrove. The Chilgrove house observation boreholes is drilled in the chalk formation of Cretaceous age, and the Hooklow South in Carboniferous limestone aquifer. It is important to say that both observation wells are located away from significant groundwater obstructions. So there is no influence of anthropogenic activity on them. It is interesting that the registered annual fluctuations are usually around 20 to 30 meters. This is a table, general information about the wells. You can see that the altitude of the Hooklow site is higher compared to the other site, and that precipitation is somewhat higher for Hooklow, but for Chilgrove, the median transmissivity is higher. This means that the aquifer is more permeable. The data, groundwater level variations are from the NERC Information Center, covering several decades of observations, but this is not original observation, but available historic reconstructions from a model created using the Aquimod software. Precipitation data are from a grid time series, and we have used the Palmer Drought Severity Index data as well. As well, total solar irradiance data. The method are time series spectra that are calculated by the fast Fourier transform, and the other method is partial Fourier approximation. It is used to calculate the time series of oscillations with a given frequency. You can see the data, original data, for Hooklow site in red and Chilgrove in blue. This has groundwater levels, precipitation, the Palmer Drought Severity Index, and the total solar irradiance. This is comparison of the time series spectra using the fast Fourier transform. You can see that the time series of precipitation in PDCE in both sides as partly correlated. But there is a difference between groundwater level spectra in Hooklow and Chilgrove, the upper graph. The possible reason from this is contrasting hydrogeological settings in Chilgrove and Hooklow. Chilgrove, this is chalk aquifer, and Hooklow is low permeable limestone aquifer. This is influence on precipitation on groundwater level variations. The long-term variation are calculated by the number of harmonics of the time series. The long-term variation of groundwater level in Chill Grove show better correlation with precipitation, but for Hook Law, better correlation is with the Palmer Drought Severity Index, and the long-term variation of the possible reason is different hydrogeological settings in both sites, and below these annual variations of groundwater level in Chill Grove and Hook Law wells, but we see better agreement with the corresponding cycles between precipitation and groundwater levels for Chill Grove, and for Hook Law, it's somewhat variation, somewhat only partly covered for Hook Law. Solar influence of groundwater level variations is revealed in 3 narrow frequency bands, and you see that the taller solar irradiation and groundwater level variations show relatively good agreement in phase, both in phase and amplitude. The idea was to improve our knowledge of the main factors influencing changes in groundwater levels with this analysis between groundwater level variations and solar and climate indices. The conclusions are the groundwater level variations were compared with climate indices and of wet and dry conditions, and groundwater level cycles may strongly correlate with precipitation or the Palmer Drought Severity Index, independence of borehole location and aquifer type. The obtained results are promising. We have used only 2 from the 54 UK boreholes with long time series, and we can use and analyze further other boreholes and their time series using solar cycles models, and to check influence of solar harmonics on precipitation and other climatic parameters. This research was prepared in the framework of the National Science Program and was supported by a project of National Science Fund of Bulgaria. And thank you for your attention.
Thank you. Thank you very much. We're ahead of schedule. We have plenty of time for questions, feedback, criticisms. We'll welcome any questions you might have or comments on the presentations for the Q&A session.
Thank you very much. I have one question for the presenter, Mr. Nikola Bobchev. Sir, thank you very much for your very comprehensive presentation related to the microplastic. My question is it possible to determine the main source of these microplastics?
Yes, it's possible, but we didn't have the unit to analyze the different types of plastics. If you have FTER spectroscopy, you can identify fibers. For example, this is polypropylene, this is PET, and PET is for plastic bottles, for example. But we didn't have this unit in Bulgaria.
Thank you very much. Sir, it concludes the last panel of the conference named Water Resources and Management, and I would like to hand over to you.
It's very easy to hand over the floor. Thank you very much. Actually, we are a little bit short time for questions and answer for general remarks. No, stay here. Don't leave me alone, please. Yeah, maybe I would like, first of all, you've been a moderator for three panels. Maybe you are the best person who can say us some conclusions for these three panels and some very interesting thoughts, and if we can discuss something.
Sure, yeah. I mean, I'm not an expert. I'm a historian by training. I do leadership, political thought. I've been new to the center since November. And thanks to Captain Zavara's encouragement, I've been involved in different projects. And of course, you've been very supportive of our activities. We're having a new cultural property course in September. And I think the center reflects, I mean, the conference was great. I mean, Colin Yursky, Colin Sasha Alexandrov, Mrs. Pavlova did a great job organizing the conference. The conference reflects a multidisciplinary, multi-ethnic, multinational character of the center. And I was just thinking that some of the papers I was able to attend and understand, because some of them were pretty specialized, were extremely helpful in terms of clarifying how crisis management relates to the center's function and mandate. I think there's a lot of potential in the center for new work, new approaches to crisis management, disaster response. The training activities are great, and I'm very appreciative as an academic of the chance to be here, and I'm very grateful for your support and your understanding, sensitivity to academic work. Thank you very much.
Thank you. Thank you, actually. Robert, please, as the director of the conference, the floor is yours here and next to me. And just everybody to see who organized this wonderful conference, and maybe some words from your side.
Thank you very much, sir. I just want to thank you very much for all the participants. We have, I think, 52 participants from, I think, 5 nations. And I would like to thank you very much for sharing the knowledge and sharing your research among us. Thank you very much.
Yep. Actually, if we are looking of Professor Sirius, maybe we'll be around 10 nations, because he is from Finland, living in Turkey, working in Italy, and what else? Yes, and it's yes, and from Greece. Anyway, thank you first of all, and Professor Sirius, I would like to give you actually my certificate of appreciation for you. I would like also Darius here, because he was our moderator for first 2 panels. And thank you also to Darius. Thank you very much. And also, maybe one picture all together to me. Yes, here. And maybe also I would like to the last panel to give the certificate of participation of Tatiana Orechova. the last certificate from Nicola Bobchuk. Plamen, if it's possible, one picture with the moderators and the director of the conference. You're director. Come on. Thank you very much. Thank you very much again. Thank you, Darius. Thank you. And now it's time actually for closing remarks, and I would like to give the floor of our special guest, General Major Tony Wright, who came exactly to this conference. Please, General, if it's possible to share with me the screen. And, of course. Yes, and maybe some thoughts from your side, and maybe to say some words to our participants and as a closing remarks for the conference. And,
yes, certainly, and I really appreciate the opportunity to be here. I'd like to start by thanking you personally for the invitation here to the Crisis Management and Disaster Response COE and your conference here. To be in Bulgaria, this is the first opportunity I've had to be here, and it's a great experience for me, and a beautiful city, and appreciate the invitation to be here. And again, I'll be here tomorrow and look forward to spending time with you and your team and learn a little bit more about what we do here. And although I've only been here for the final closing part of the sessions here, it's really impressive whenever I look at the breadth of what you've covered in this 10th annual conference. The challenges that each of you have been considering these last few days reflect the scale of the issues that we're dealing with here with the nations and with the alliance. NATO has to consider the changing strategic environment, which includes climate change, obviously, energy security, emerging and disruptive technologies, and demographic changes, just to name a few. And every effort to build and share understanding of the complex problems, that's going to assist in developing common approaches for the alliance to mitigate the risk and overcome them. Two aspects that NATO is extremely focused on right now, and they'll be reflected in the forthcoming 2022 strategic concept, is how we consider the impacts of climate security and the requirement for digital transformation, and to support agile data sharing and decision-making across the alliance. The fact that your conference covered both of these salient topics speaks volumes about the foresight, the solutioneering, and engineering that you programmed into today's problems to help NATO solve those challenges through the work of your Center of Excellence. So really appreciate that. I like Command Transformation has the luxury to be able to do the horizon scanning for NATO's military instrument of power. And the NATO Warfighting Capstone concept is a tool through which we'll lay out the warfare development imperatives as we move forward to maintain a decisive edge to 2040 and beyond. I know that the CMDR here has contributed to the initial thinking, and trust that you will sustain your efforts to turn that 30,000-foot concept into deliverables through which NATO can deliver through the warfare development agenda. One of those imperatives that we're working closely on is layer resilience, and considering the needs for military resilience, also how it links with civil resilience and interdependencies between those two, and how the implications for society in general, the broader society. Also, we're looking at the overlap with crisis disaster management. Is clear between what we're working for on resilience and what we're working for here with the COE. So appreciate your continued efforts there. Resilience, as we define it, is the capacity to resist, to overcome shock, to absorb the damage, and resume functions as quickly and as efficiently as we can. Resilience is therefore about adaptability, agility, and ideally the ability to undertake alternative ways, which requires flexibility regardless of the shock being natural or man-made. It's of utmost importance to have a holistic understanding and recognition of where the shortfalls and vulnerabilities exist and the factors and trends that shape them. This will help the Alliance determine risk, also to prioritize our mitigation of those risks, and then strengthen enablement, provide a readiness response And so these elements are all equally important for resilience. From a military perspective, to be effective, resilience needs to compromise the right capabilities, which means the means to fight, and then the right strategies and doctrines, which are the ways to fight, and then follow it up with the spirit to fight, which is really the will to fight. Today, we see that the risks of our societies are not only coming from state and non-state actors, but also what we might term as threats without threateners, things like pandemics, rising climate challenge, and which all put an increasing pressure on the importance of resilience and our ability to be resilient and flexible. Discussions today, as per the last few days, are pivotal to creating the momentum necessary to build the right capabilities and deal with all those threats. Teamwork and understanding that will allow improved procedures, strategies, and ways to operate across the whole of society are vital. And as we deliver these means, we build a trust between us all, whether military or civilian. Trust that will be essential to act as one when faced with crises, which will obviously happen at some point in the future, again, whether those are man-made or natural disasters. We know that something's on the horizon we're going to have to deal with. So again, on behalf of General Levine, who's the Commander, Supreme Allied Commander Transformation, thank you for your participating. And thank you all for participating in the conference here. And Warren, thank you so much for your efforts here with the COE and your time. And I look forward again to the future challenges that we'll face, providing new perspectives on those. And also, we'll continue to share and learn and win as a team. So thank you very much. I really
Thank you. Thank you very much. Thank you. Yeah, it's a very valuable actually estimation of our conference, and this is just the beginning because this conference was very interesting from that point of view. That for the first time we made it something between military and scientific conference. And from that point of view, yes, it's true. The resilience is one very wide area which we are trying to cover, and that's why we included in climate change inside and military activities and graphic information system. You saw the water problems and some all these issues which are related with climate changes, also modeling and simulation system, architectures, disaster response, and very wide spectrum. That is our idea actually to cover all aspects from military and civilian point of view. And I think that we will continue together with Bulgarian Academy of Science, with National Institute of Meteorology and Hydrology. And we'll continue our efforts to cooperate together with civil society and to achieve better results for the military, of course, and in partially for nations and NATO, of course, as an alliance. Of course, and collaboration with the European Union is very important for us, and we will continue to be more strong this relation between NATO and European Union nations, and of course, including all partners, Partnership for Peace, Mediterranean Dialogue, Istanbul Initiative, global partners, countries, and we will try to provide all these capabilities and need for improvement for all of us. Nina, are you here?
Yes. Hello, everybody.
Yeah, I would like also to especially thanks to you because I know because of your efforts, most of all articles actually will be published in Springer. Sorry,
yeah.
Springer.
That's confirmed.
And yes, and the rest of the articles will be published in our publication, annual publication on the CMDR COE proceeding. Please, your closing remarks and your closing words, if it's possible.
Thank you. Dear colleagues, I'm really glad that we have you all here. As Orlin said, this conference was quite a challenge to have a combination between military and academia conference. As a first conference of its kind in Bulgaria, we had some challenges, but I believe we overcome them. And for the next to come, I think we are going to be much, much better. Thank you all again, and I'm happy that we organized this conference this year.
Yeah, I would like also on my and your behalf to thank you also for Bulgarian Academy of Science, National Institute for Meteorology and Cardiology for their support of the conference, and all our sponsors who participated in the conference. Dear participants, it is a great honor actually for me to congratulate you on the completion of the second International Conference on Environment Protection and Disaster Risks, and in the same time 10 Annual Conference on Crisis Management and Disaster Response. Our Center of Excellence has been devoting efforts to addressing the importance of crisis management and disaster response process in a global environment, environmental risk, and implication on all aspects of life and high-performance computing. The unprecedented pace of environmental degradation, which threatens the existence of ecosystems and leads entire species to extinction, is deeply intertwined with human activities. I strongly believe that this year's conference achieved our goals. Attendees were introduced to global warming as a phenomenon and multiplier of security threats, discussed the main factors that affected the environment, assessed the impact of climate change on international peace and security in the short, medium, and long term, and consider integrated options to address these climate security challenges. Moreover, it is clear that the ability to simulate and predict weather phenomena and effects is critical to the improvement of operations in the crisis management and disaster response domain, and hence necessitate you in decision-making and planning processes. Let me express my appreciation and gratitude to all of you, our attendees from the CMDR community of interest, subject matter experts from NATO allies and partners, the academia and the private and non-governmental sectors. Thank you for your desire and efforts to become part of our team. I'm sure that this collaboration will continue through the years, and even we started the next conference now. I would like also to express my and all the organizers' sincere gratitude to the guest lecturers. Thank you for your comprehensive expertise and the time dedicated to this event. To all of you, I wish to stay safe and healthy in these uncertain times and to have future opportunities for collaboration. Finally, I would like to thank you also to our technical staff, even in front of me, leading with Dmitry Dimitrov for their efforts, because they made it really wonders to these 4 days to provide in hybrid mode broadcasting in the same time, live lectures and online lectures to be everything to go smoothly. Thank you very much to the all staff of the CMDR COE and Nina Dubinko, of course, for support of the conference and organizing the events. Congratulations to all of you on successful completion of the conference. And finally, I would like to thank you also to Allied Command of Confirmation in face of General Major Tony Wright for their support of our conference. We will continue actually after the conference our talks and future perspective, what and how we should continue. But finally, I would like to thank to the director of the conference, Colonel Robert Yursky, who dedicated first conference in his life, maybe from the beginning to the end. He saw that it's not so easy, but sometimes it's funny. And the next task actually started immediately after 10 minutes when we finish to organize the next conference for the next year in the beginning of June. All of you, you're invited again, and please welcome. I would like also to give our thanks to the General for thanks to you and of the memory from this conference and your visit in the center. Thank you very much, and that was all. See you next year again at the same time.
Thank you.